Okay, so today what we're going to work on are solving rational equations when f of x is equal to g of x. So remember this from before when we did a system of equations, f of x is equal to g of x. I'm only looking for the x value. I'm not looking for the y values because this is saying find when y is equal to y. So you want to find your x value. All right, so it is the same process as before. All right, we're going to set the equations equal to each other. So just make sure they're both y equals. Okay, you're going to follow the same steps as yesterday. You're going to factor the denominators completely. You're going to find the LCD, the least common denominator. Multiply the numerators by the LCD. If you have a hard time finding the LCD, just multiply the numerators by what will help you get rid of the denominators. If it's a number, just multiply by the LCD. Don't multiply by a whole bunch of different numbers, integers. You're going to reduce, solve. Be careful if you have a subtraction sign that you distribute, and you always check for extraneous roots. All right, so let's take a look at the first one. We have here f of x is equal to 1 over x plus 1 over 6, and g of x is equal to 1 over 1 half. So I'm looking for when they're equal to each other, so I set them equal to each other. So 1 over x plus 1 over 6, that's your f of x, equals your g of x, which is 1 half. All right, so first thing I check to see if I can factor any of my denominators, and I can't because these are all monomials. All right, so let's start with the 6 and the 2. I want to get rid of the 6 and the 2. Now, I'm looking at both of them at the same time because I don't want to multiply all the numerators by different numbers. I want to get rid of the numbers with the same number. I want to be able to reduce. So what number can I put up top in the numerator so that I get rid of the 6 and the 2? All right, you got it. So that would be a 6, all right? If I multiply the numerator by 6, that gets rid of, this numerator gets rid of this. If I multiply the 6 here, this will reduce with the 2, become 3. And remember, whatever you do to one, you have to do to the other. So I have to multiply that by 6. All right, now multiplying this one by 6 won't do anything with the x. So what do I need up top so that it reduces with the x? Well, I need an x. So I multiply all the numerators by x. So that's my LCD. My LCD is actually 6x. So now I'm going to reduce. So x and x reduce, so I'm left with 6 plus 6 and 6 reduce, so I'm left with 1x equals 2 and 6 reduce to 1 and 3, so therefore I'm left with 3x. And now I'm going to solve. Minus x, 6 is equal to 2x, divide by 2, x is equal to 3. And always just make sure that you don't get anything that's undefined, so plug it in, make sure it works. Okay, so we have, you can put, and you can use your calculator for this. So it's 1 over 3 plus 1 over 6 equals 1 over 2. Yes, 1 over 3 plus 1 over 6 is 2 over 6. So it's 3 over 6. Hold on, let me move everything up. So I'm plugging in, so it's 1 over 3 plus 1 over 6 equals 1 over 2. So this here, so you can plug this, just plug that in your calculator. You get 1 half is equal to 1 half, so that's good. That checks. All right, let's try number 2. All right, so I have f of x is equal to 1 half plus x over, plus 5 over x minus 2, and g of x is equal to 3. So I'm going to set them equal to each other. So I have 1 half plus 5 over x minus 2 equals 3. All right, so I look in the denominators to see if I can factor. I cannot factor x minus 2. All right, so I notice I have a 2 here. And actually what I'm going to do is I'm going to put the 3 over 1. So now I have all fractions. So I want to say to myself, what do I need up top here to get rid of the 2? So I need a 2. So I'm going to multiply everything by 2. 2, 2. Now, because this is a binomial, this 2 does not reduce with this 2. So now, when you have a binomial, put parentheses around it so that you know it's grouped together. So you can't take this 2 away from this 2. So then you have to think of this as one whole thing. So what do I need up top to get rid of the x minus 2? So you need an x minus 2. So that means multiply everything by x minus 2. All right, now we're going to reduce. So 2 and 2 reduce. So I'm left with 1 times x minus 2, which is x minus 2. X minus 2 and x minus 2 reduce, so I'm left with plus 10 equals. Nothing at the end reduces, so now this 3 times 2, that becomes 6 times x minus 2. All right, so now I have x plus 8, I combine like terms, equals 6x minus 12, distribute. And now let's solve. So I'm going to subtract x. I get 8 equals 5x minus 12. Add 12. Add 12, so I get 20 is equal to 5x. Divide both sides by 5, and we get x is 4. And now we're going to check it. So checking x is 4, so I have 1/2 plus 5 over 4 minus 2 equals 3. So it's 1/2 plus 5 over 2 equals 3. So that's 6 over 2. So this you can plug in your calculator. 6 over 2, which is 3, equals 3, and that checks. All right, so let's take a look at number 3. Okay, so the same thing. I have f of x is equal to x minus 2 minus 8 over x plus 3 over, and g of x is equal to 10 over x squared plus x minus 6. So I'm going to set them equal to each other. So x over x minus 2 minus 8 over x plus 3 equals 10 over x squared plus x minus 6. All right, so now I notice right away in the denominator here I have this trinomial. So I have to factor that. So I'm going to factor it over up top here on the side. All right, so let's see here. I'm just going to factor x squared plus x minus 6. So I mass the product, I get negative 6x squared. So what multiplies to 6 gives me a minuses to 1. That would be 3x, positive 3x and negative 2x, minus 6 and x squared. And now I'm going to group. GCF is x times x plus 3. GCF is negative 2 times x plus 3. So this is my denominator, x plus 3 and x minus 2. Usually when you have rational equations, when you have a trinomial, it usually factors to become at least one of these or both of them. Okay, so I'm just going to rewrite this. So I have x over x minus 2 minus 8 over x plus 3 equals 10 over x plus 3 times x minus 2. Okay, so now let's see what we have here. So I have all these binomials in the denominator. So put parentheses around them so you know it's grouped together. So now you say to yourself, what do you need up top to get rid of the x minus 2? So you need an x minus 2. So remember, whatever you do to one, you have to do to all of them. So the x minus 2 at the end will take care of this x minus 2. The x minus 2 here doesn't do anything to x plus 3, so that means you have to multiply everything by x plus 3. All right, so now you're going to reduce. So x plus 2 and x plus 2 reduce, so I'm left with x times x plus 3 minus x plus 3 and x plus 3 reduce, I'm left with 8 times x minus 2. X plus 3 and x plus 3 reduce, x plus minus 2, x minus 2, so I'm left with 10. Now we're going to distribute. Watch that negative. X squared plus 3x minus 8x plus 16 equals 10. Combine like terms, we get x squared minus 5x plus 16 equals 10. Okay, so let's subtract 10 from both sides. So I get x squared minus 5x plus 6 equals 0. And now let's factor. So we'll do the master product. So I get positive 6x squared. What multiplies to 6 adds to 5. That would be 3x and 2x. And they're both negatives, so get negative 5. And now we will factor by grouping. So the GCF is x times x minus 3. GCF is negative 2 times x minus 3. So my factors are x minus 2 and x plus minus 3. My zeros are x is equal to 2 and x is equal to 3. All right, and now you have to check. So just really quickly, I know that this one here, the x equals 2, is not going to work because when I plug in 2 here, into the denominator, I'll get 2 minus 2. I'll have 2 over 0, and that's undefined. So that can't happen, so I have to cross that out. That's called an extraneous root. It's an extra root. It's a root that doesn't work. And 3 will work, because when I plug in 3 here, I'll get a 1. 3 here will give me a 6, and the rest will be good because those are just factors. That's factors of, those are your factors. All right, so my answer is just x is equal to 3. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.